In this video, the viewer will learn how to quickly set up a small Trio K-Series license-free serial radio system to perform a test or a demonstration using the built-in Wizard tool. You can see on the left side of this image that the master radio is configured for a transmit power of 20 dBm, which is 100 milliwatts. It is connected to a computer to configure the radio and to perform diagnostic testing. The master radio is connected through a short feeder tail or jumper cable to a Trio 4-port RF attenuator. The attenuator provides about 80 decibels of attenuation between any two ports. We have another RF feeder tail cable connecting to the remote radio and to a bridge radio. Because the master is configured for 20 dBm transmit power and we have 80 dB of attenuation, we can expect the received signal strength to be approximately minus 60 dBm. The box at the bottom of the screen shows the hardware required for this demonstration. Alternately, antennas can be used instead of the attenuator and cables. However, using the hardware shown here provides repeatable results with no concern of interference. Here we can see the programming and diagnostic cable used with the K-Series radio. It is connected between a computer's DE9 serial port and the radio's system port. The Trio K-Series serial radio can transport several different data communication protocols on a single radio channel by assigning each data stream a 1-byte value called the stream ID as messages enter the radio. At the far end of the link, messages are routed to the correct port using this stream ID value. Trio K-Series radios may be configured for several different network types. In the point-to-multipoint type network, the master radio at the SCADA host location must be able to hear all remote radios directly. If the area to be covered is larger, or there are obstacles requiring a repeater, the master radio itself may be configured for peer-to-peer repeating mode. This is also called quickstream mode. A master radio which receives a message to be repeated can retransmit it during the same hop interval if there is time. A bridge repeater must instead wait until the next hop interval to retransmit any messages. If the area to be covered is very large or there are many obstacles, it is possible to include multiple repeaters in series or in parallel, or both. In this case, the repeating radios must be configured as bridges. This radio type spends one hop interval as a remote communicating with its master. On alternating hops, it becomes a master and then can forward messages down to its own subnetwork. This is the main page of the TView Plus Management Suite software. TView can be used to configure any of the serial Trio radios, to upgrade firmware of several radio models, or to perform diagnostic testing of any type of Trio data radio. For now, we will open the K-Series programmer in advanced mode. Typically, the first thing that is done is to go to the settings menu. Here, we ensure the baud rate is at the typical 19,200 and that we have the correct COM port selected. It would also be a good idea at this point to connect the programming cable between the computer and the radio's system port. For anything other than very complex configuration, the wizards are very useful. First, we need to click the read button to open a programming session with the radio. A local read is done unless configuring a distant radio over a working system. Note the connected indication at this point. After opening a connection, we click the wizard button. This brings up a list of several network types. A point-to-point connection is basically a wire replacement. The three network types discussed earlier are all options as well. If you click the point-to-multipoint option, note that two radio buttons are available, master and remote. This page also lists all parameters that are pre-configured by the wizard. Note that if the point-to-multipoint with quickstream wizard is chosen, the master radio will be configured to repeat all user port stream IDs. It can be seen here. It can also be separately configured to repeat diagnostic messages. We'll now go to the point-to-multipoint with bridges wizard. For this demonstration, we will configure three radios, one as master, one as a single antenna bridge, and one as a remote. We'll first click the master button and click OK. This pre-configures numerous items. Note the radio type is master. The serial ports are pre-configured. The transmit power 20 dBm, the radio data rate 128 kilobits per second, and the network type is point-to-multipoint with bridge. All that must be done for this demonstration is to enter a subnet ID, which is also known as a network name. We'll enter the name main here. This is case sensitive. Typically, it would be a good idea to save the configuration at this point, but for this demonstration, we'll just click the Write button to send the configuration to the radio. As soon as the radio is configured, the power LED will begin flashing red to show it is sending synchronization packets out to any remotes. Once the configuration has been written to the radio, the connection will close. We now move the programming cable to the bridge radio system port, and we'll do a read to open a local programming session. We then again go to the wizard dialog, select point to multipoint with bridges, and then select bridge with single antenna. All we need to do here is enter two network names. The upstream ID will be main to match the master radio. Then we enter a new downstream ID to allow this bridge to synchronize its own subnetwork. Any text will work, but the name sub1 will be entered here. Next, we write this to the radio. A few seconds after the configuration is written to the bridge, its sync LED should begin flashing green to show it is now synced to its master. The power LED will flash red to show that it is sending sync messages out to its own remotes further downstream. Next, the programming cable is moved to the remote radio, and again a read is performed. We will again move to the wizard dialog and the link extend bridges option, and then select a remote radio. Here now all we need to do is enter the network name sub1 and press the Write button. Within a few seconds, the remote radio's sync LED will begin to flash green to show it is now hopping in sequence with the bridge. Finally, it is important to be able to test a radio system once it's configured. First, we need to close the K-Series programmer to free up the serial port. Next, we will open the TView Diagnostics software. The first thing to do is to go to the Settings menu and Controller Settings. Ensure that the COM port is the same as used before and the speed is 19,200. If you've made changes, click Apply and Exit. We then go to the File menu and select New, and we're going to create a database here. This opens a dialog that allows us to enter each of the radios in turn. First, we enter the master radio, set its model to K-Series Master, and enter its serial number. The serial number is 502854, and note that the stream ID code for Diagnostics is 0 as shown here. We click Apply Changes and click Add New. We'll enter the bridge now and its serial number 502776. Change the model to bridge and click Apply. Add the third radio, the remote, and this is a remote. Serial number 503110 is what I have documented. We'll apply these changes, then we can exit the dialog. Next, we can click the Group Poll button to begin polling all of the radios in the database. We're currently connected to the remote radio, but messages will be passed to all radios in the system. You can see the received signal level is approximately -60 as predicted. The individual poll dialog can be used to poll a single radio. As we're connected to the remote, polling the bridge would generate over-the-air traffic. We click the toggle button and get a bar graph view of the diagnostic parameters. We can close this dialog now. In the Tools menu, there's also a parameter here in Statistical Performance, a test called the Packet Transmission Test. We select a radio at the far end of the link. Here the bridge will do, and we click Start. And this generates test packets which are looped back by that destination radio. We can let this test run for several minutes and then click the Finish button. When done, we click the commissioning record button, and this generates a report which we can print and save for future use. Thank you for watching this video, which demonstrates configuration and diagnostic testing of the Trio K-Series serial radio using the Setup Wizard and TView Diagnostics.